Hello students, how are you? Question 7, it says the opposite graph shows the variation of potential difference and charge of a capacitor. Okay, study the graph and answer the following questions. The first A, it says what is the potential difference across the capacitor? Okay, of course here after it stopped charging. As we know, when we connect any capacitor to any power supply, okay, the electrons will go from this side and they will accumulate or gather on this plate of the capacitor, okay, and this will make 4 of them to escape from the other one. So this one will be 4 positive. Of course here 4 charges is like a random number, and this takes time. Okay, so when the potential difference in the capacitor equal to the potential difference of the battery, there will be no increasing of the charges on the 2 plates. Okay, so what is the potential difference on the capacitor? It's actually the value of potential difference when it stopped increasing. As you can see here, it increased right here until it became constant. It means the voltage or the potential difference is actually 20 volts. Okay, so the voltage is actually 20 volt. Okay, because it stopped increasing at 20. Okay, now find the capacitance of the capacitor. We know that capacitance is equal to charge over voltage. Okay, notice here in the graph, charge is on the x-axis and the voltage or potential difference is at the y-axis. So basically the capacitance here is actually the change of x over the change of y. Okay, and this is the 1 over the gradient. I will represent the gradient as g. Gradient is the same as slope. Of course, you know that. So first of all, I will find the slope or gradient, and then I can find the capacitance. Okay, let me divide here. Okay, I will find the gradient right here. From math, we remember that gradient is actually the change of y over the change of x. I can say it is y2 minus y1, okay, over x2 minus x1. From where I get the x2, x1, y2, y1, I choose 2 points randomly from the graph. I will choose, for example, this point right here and this point right here. So the 20 is actually the y2 and 10 here is the y1. Okay, I come right here and I notice here that the value here 80 is actually x2 and the 40 is the x1. Okay, so gradient equals y2 is 20 minus y1 is 10. Down I have 80 minus 40. I just want you to pay attention here to the x-axis, and all the values are multiplied by 10 to the power negative 6. So basically here it's not 80, it's 80 multiple 10 to the power negative 6. The same here, 40 multiple 10 to the power negative 6. That's why right here I'm gonna put brackets multiple 10 to the power negative 6. Okay, I didn't do that with the y-axis because notice here it is in volts. It's not in for example millivolt or kilovolt, and all the values are not multiplied with any value. That's why I will keep the 20 and I will keep the 10. Okay, so the answer here will be 0.25 multiple 10 to the power 6. Okay, so I go back here to find that capacitance. So capacitance equals 1 over gradient, so it is 1 over 0.25 multiple 10 to the power negative 6, which equals 4. Sorry, here not negative, sorry, it is positive. Okay, equals to 4 multiple 10 to the power negative 6. Here it is negative, but down here it is positive. Okay, so this is the capacitance C. In the third here, in part C, they want find the energy stored on the capacitance. Okay, let me change the color. I will choose the green. Okay, so energy equals to half C V squared. Okay, we have the C and we have the V, so it equals half C. We found it right here. It is 4 multiple 10 to the power negative 6 multiply V squared. We found the V right here. Okay, it is multiple 20 squared, and this will give me 8 multiple 10 to the power negative 4 joules. Okay, the unit of energy is joules. In part D, they want how can we increase the energy stored on the capacitor. This is the formula of energy. In order to increase the energy, we can increase the voltage. If we increase the voltage, this will make the energy increased also. Okay, so we can change the power supply. We used a bigger one or stronger one. Another way is actually by increasing the capacitance. We can increase the capacitance, and this will make the energy increase also. Here in the capacitance, I can talk more in details, as we know that capacitance equals to epsilon A over D. So when we increase the surface area of the plates, this will increase capacitance. Okay, so when we increase the area, this means that capacitance will increase, and this means that the energy will increase. Another way, we can decrease the distance. This is D, by the way. Okay, sorry for my bad handwriting. Okay, let me erase. When we decrease the denominator, this will make the C increase. So when we make D smaller, it means we bring the plates closer to each other. This will increase the capacitance, and it will make the energy increase also. Another way is actually here, increasing the epsilon. Epsilon here, it is related to the type of material or medium between the plates. Okay, we can use a dielectric material. For example, we can use glass or plastic or any material that will make, when we increase the epsilon, okay, it has a bigger value. This will make C bigger, and this will make the energy bigger also. Okay, I hope it's clear, guys. I still have part E. I'll use the blue for that. If we use a power supply of 30 volt, what will happen to the energy stored? Of course, a 30 volt power supply means that of course the potential difference, it was 20, now it is 30. So as we discussed right here, the voltage increases means that the energy will increase. Well, let's check that. So here the energy, it's half CV squared, so it is, this is 2 by the way, half multiple the capacitance is 4 multiple 10 to the power negative 6 multiply 30 squared. This will give me a new value of energy. It is 1.8 multiple 10 to the power negative 3 joules, and as you can see, this value it is bigger than this value. So when we increase the voltage, the energy increased. Just want to remind you of a simple math note. Please remember to compare these two numbers, this and this. It's not just about the numbers, it's also about the power of the 10. In here down I have the 10 to the power negative 3. It means the number is bigger than anything with 10 to the power negative 4, right? Because this one I can write it as 18 multiple 10 to the power negative 4. So of course the 18 is bigger than the 8. I'm sure you know that. I'm just reminding you. Feel free to watch the video again if you want to remember these information better, and if you have any question, please leave it under the video. I'll see you later. Bye bye.